Good morning. Today we talk about something really important. Let me just try to draw this. Well, as you can see with three oxygens, this one is called nitric acid, okay? Nitric acid. So with only two oxygens, we call it nitrous, okay? So it is called nitrous acid, okay? So in French, it would be nitreux. Voilà, acide nitreux. Okay, so you need to know this reaction. So starting from a nitrate, the nitrate, which is the nitrate, is NO2. Okay, so NO2, we can write it like we can like. Generally, it is like this, NaNO2, okay? So plus and minus here. So we say NO2 like this. Under acidic conditions using HCl, so we are going to form, well, let me try to write the mechanism, it would be better. So we are going to form like this to grab a hydrogen, and then we form, well, not minus chloride, we form an oxygen, and then we form OH. This is what we just wrote here. Sorry, this is what we just wrote here, HNO2, okay? HNO2. Nitrous acid, okay? So whenever we form a nitrous acid, like another like reaction with HCl is like probably we can find this reaction again. So we are going to form, like try to do the same thing. We're going to form well, another molecule which is NO and nitrosonium, okay? So we lose a water molecule, so a loss of a water molecule. So here we are forming NO, and then something is going to be lost, which is a water molecule, OH2 plus, okay? So this is the nitrosonium, okay? So I need my lone pair here on the nitrogen, and a negative formal positive charge, okay? So either I write this one or this form, or this form. I write this like this. 3, this one is going to be fold here, and we form this molecule. So both of them are nitrosonium. Okay, nitrosonium. Okay, so now we need to know that NO plus, the nitrosonium, is an electrophile. Okay, electrophile. Well, well, sorry for that. Well, let me just show you something very important right now that you need to know. The reaction between an amine and NO, okay, a nitrosonium, okay? So in general, and as we could see in a video before, in the video of maybe penacolic rearrangement or semi-penacolic, we could find something called, like a reaction between, recall the reaction of pinacolic, it was NH2 here, we had NH2, and then we reacted this molecule with HNO2, okay, so, and we said that this molecule with this one gives N2. How could we say that? Because, well, because NH2 under acidic conditions is going to, as we just said before, it's going to form NO plus, okay, so nitrosonium, and then the nitrosonium, it is going to react with NH2 to form N2, okay, well, sorry, N2, okay, so this is what we are going to do right now. We are going to write the mechanism, okay, so I'm gonna write the mechanism of this reaction. So let me just write, well, R1 NH2, okay? So I have an amine, this is my amine, and I need a nitrosonium, okay? I'm not gonna write HNO2, I'm gonna write NO plus, okay? NO plus. Well, what are we going to do? We are going to attack, like this amine, it's going to attack the nitrogen. So we are going to form NHH and, sorry, N and an oxygen here, okay? So we are forming 1, 2, 3, 4, 5 bonds. So this nitrogen is going to be neutral. However, this one, it is attached to 4 atoms. So it has a formal positive charge. So right now, what are we going to do? So we have this form of resonance like a positive charge, a sigma bond, and a lone pair, okay? So we are going to, let me just zoom in, sorry, focus on this molecule. So we are going to use, well, before we do this, like we have to, like having a positive charge on the nitrogen, it's not a good idea, okay? So it is something that the nitrogen doesn't like. So we have to have to grab this hydrogen and make our molecule neutral again. So I redraw it again, and with only one H this time, a lone pair, and another one with a lone pair with an oxygen, okay? So what are we going to do right now? We have a lone pair, sigma, a lone pair, okay? So a lone pair, sigma, a lone pair. So we have a resonance form, okay? So we can make a tautomerization. We can find that it is going to make tautomerization. So let me draw it this way. It is going to be it is going to be like this. Oops. Well, like this, and then the oxygen is going to be like this. So I have to draw R1H, and then here we have a P bond between the two nitrogen atoms, like this, and then an alkoxide, okay? So this alkoxide is going to grab a hydrogen, so it is going to grab this one, and then we are going to form R1 and, sorry, I just, well, this one. Okay, sorry. Well, a nitrogen here and then an OH. Okay, so remember that we need to form N2. Okay, this molecule. So we do have N2 here. So what are we going to do? We are going to react this molecule with HCl so that we can grab a hydrogen, and then when we grab the hydrogen we form a water molecule. This one is going to be a water molecule, which is a good leaving group. So we have R1 and this and this, so it is going to leave. Okay, how it is not going to leave like this, but there is something that we are going to do before. So let me just write it here. OH2 plus. So this is our good leaving group. Okay, good leaving group. So we need to grab this one here, and here we had a lone pair here before. Sorry, I didn't draw it, and we need. It is going to. Sorry, it's not going to fold. The OH2 plus is going to leave. Okay, so we are going to form this molecule that I'm going to draw here. R1 with a nitrogen and another nitrogen, but a three bonds. Okay, so this one and two and three. Okay, so and we still have this lone pair here, so we are going to draw it here. Okay, so this is our molecule, but we have to add a positive formal charge on this nitrogen. Okay, so because it had a lone pair and now it has no lone pairs, so yeah, a loss of water molecule. Okay, so here we do have our chloride of benzene. Maybe no, if we had pH here, we would say benzene diazonium, but in general we don't care. Here we have R1, so this is a diazonium. Okay, well, this is very important for aromatic substitution, like for aromatic reactions. Okay, so yeah.